All right. Hopefully this will be a little bit more coherent than the last ones, because we're just going to go through the slides here. I know that'd be a little bit boring, but we're going to, and what we're going to cover is sections 2.1, 2.2, 2.3, 2.4. You already have an assignment over those that's due a week from Friday. So the problems aren't hard, and we'll do probably half of them in class over the next uh, on Thursday and Tuesday. And even though we will start again on Tuesday to finish chapter 2, we'll just keep moving. We'll just keep moving. So here we go. All right. So when the motion, when it flies through the air in any change direction. All right. So what we're talking, it's got speed, velocity, and acceleration. Displacement, speed, velocity. You might be going, is there a difference between speed and velocity? Yeah, we'll get to that in the next little thing. All right. These cyclists here, we can describe them by their displacement or by their travel. Now, displacement is different than distance. Right? Let me show you the difference. So the difference between displacement and distance. All right. So here we go, displacement, distance, and then we'll look at their slides here, okay? So here we are. So let's go here. Displacement versus distance. It's real simple, okay? It's real simple. Okay, so I'm going to go from here to here. This is 1, 2, 3, 4, 5, 6, 7 meters. 1, 2, 3, 4, 5, 6, 7 meters. Okay, I'm walking down a hallway. I start here at 0, and I go to here, and then I come back to here. All right, and then I go to here to 6. Okay, my displacement is where I started, subtracted from where I finished. That's displacement. So x final is equal to 6.0 meters. X initial is equal to 0. So my displacement, my change in x, is equal to x final minus x 0, which is equal to 6 minus 0, which is 6.0 meters. Not too hard. My distance I traveled, though, let's look at my distance. My distance, I went 2 meters. Then I went back 1, so there's 3 meters. And then I went another 5 meters. So my distance, this is displacement. So my displacement was 6 meters. My distance is all absolute value. Everything's that. So I went plus 2 meters, plus I went positive 1 meter, I went back a meter, absolute value minus meter, plus everything's an absolute, plus I went from 1 to 6, which is plus 5 meters, positive 5 meters. So I've got 2, absolute value of 1, 8 meters. That's my distance, okay? There we go. All right. And that's what they're talking about here. X final minus x, that's 2 meters. I know it all seems like, wow, it's really that hard. Okay, now notice, his displacement is negative. He got up from his seat here and went back here. Yeah, he's on a plane. He's going to the magazine rack. Right. He's waiting to go to the head. But anyway, it's 6 meters to 2 meters. So the final is 2 minus 6, which would be negative 4 meters. His displacement is negative 4 meters. His distance is 4. You understand? Good. All right, this is basically what I did here. Okay? All right, so the motion, distance traveled. All right, so the distance traveled is a scalar quantity, or its displacement in a specific direction is a vector quantity. All right? So distance is a scalar, displacement is a vector, because I went a distance. This was 6 meters. All right, so this guy here, whoops, That's the book. This guy is 6 meters in the positive x direction. Okay? Positive along the positive x-axis. That's the magnitude and direction. Okay? That's the magnitude and direction of this. This is just nothing but this is just nothing but there's no direction. So this is a scalar, no direction. And we'll look at velocities are the same way. So let's go ahead and stop this right now. Stop this nonsense. Stop the foolishness.